This meeting is being recorded.
For problem 15, in chapter 7, we're asked to identify both the major and minor products for these elimination reactions, these E2 reactions that are shown below. So these substrates are given in parts A, B, and C here, and we're told that they are treated with a strong base. So what you see here are the substrates in black, and what I've drawn in are the protons on the beta carbon that can be used in an elimination. So this first compound here, we'll find this produces a product, and this is said to be stereoselective because both of these protons shown can achieve the anti-periplanar orientation or conformation rather that is needed for this elimination to occur. So we should expect that both a cis and trans stereoisomer will be our two products here. So that's what we see has happened. So say we have one proton removed with this bromine here, we could produce our major product, the trans isomer. And then say we remove this other proton with our bromine, we could produce our cis isomer, which would be our minor product. So once again, the trans will be our major, the cis would be our minor. Then we see with our substrate B here that this would produce a stereo-specific product. And we see that only this beta site here has a proton available. So first we need to get our compound into an orientation or conformation rather, where we have our proton and bromine in an anti-periplanar position so that we could deprotonate, and then we would see this leaving group with the bromine. So what we see is if we rotate this first position here, we would generate this site here. So notice that the hydrogen is in the plane of the board with the bond where the double bond will form, and the methyl group is moved up here, and now this benzene ring is on a dash. On the other carbon now, we are going to start at that site and rotate that bond so that our bromine is now in the plane of the page. So now we have this proton and this bromine in an anti-periplanar fashion, so they can be eliminated when treated with base. And this is our specific product that will be produced. And we can see that the methyl group and the hydrogen are in the same plane, the bond, and then this benzene ring and our tert-butyl group here are in the same plane of the double bond. And last, if we start with this substrate shown over here, what happens is when treated with a base, we will produce only one product, and it may appear that we would have to rotate this carbon-carbon bond, but the beta proton is already anti-periplanar with our leaving group because one is on a wedge and one is on a dash. So what we see in our stereo-specific product. So once again, this reaction here will be stereo-specific. This one product is produced, and notice that the double bond is with this methyl group. So now there's a planar geometry shown here. So there's no longer a dash.